Matter and antimatter are fundamental concepts in particle physics, which is the study of the fundamental particles and their interactions that make up the universe. Matter is made up of particles such as protons, neutrons, and electrons, while antimatter is made up of particles such as antiprotons, antineutrons, and positrons. The basic difference between matter and antimatter is that the particles that make up matter have a positive charge, a negative charge, or no charge at all, while the particles that make up antimatter have the opposite charge. For example, the proton, which is a positively charged particle, has an antiparticle called the antiproton, which is a negatively charged particle. Similarly, the electron, which is a negatively charged particle, has an antiparticle called the positron, which is a positively charged particle. When a particle and its corresponding antiparticle come into contact with each other, they annihilate each other and release a large amount of energy in the form of gamma rays or other particles. This process is called annihilation. Annihilation can also occur when a high-energy particle collides with a particle of matter or antimatter. The concept of antimatter was first proposed by Paul Dirac in 1928 when he developed a new equation that described the behavior of electrons. The equation predicted the existence of antiparticles, and the first antiparticle, the positron, was discovered in 1932. Since then, many other antiparticles have been discovered, and their properties have been studied in detail. One of the most intriguing questions in physics is why the universe seems to be made almost entirely of matter and not antimatter. According to the laws of physics, matter and antimatter should have been created in equal amounts during the Big Bang, the event that is believed to have created the universe. However, observations have shown that there is very little antimatter in the universe, and scientists are still trying to understand why this is the case. In summary, matter and antimatter are fundamental concepts in particle physics that describe the properties of particles and their antiparticles. While matter is made up of particles with a positive charge, a negative charge, or no charge at all, antimatter is made up of particles with the opposite charge. When matter and antimatter come into contact, they annihilate each other and release a large amount of energy. The properties of antimatter are still being studied, and its role in the formation of the universe is an area of active research in physics. Dark energy is a hypothetical form of energy that is believed to be responsible for the observed accelerating expansion of the universe. It is called dark because it is not directly observable, meaning it does not emit, absorb or reflect light, and its nature and origin are still not well understood. The concept of dark energy emerged in the late 1990s when astronomers observed that distant supernovae were moving away from us at an accelerating rate, which indicated that the universe was expanding at an ever-increasing speed. This observation was unexpected, as scientists had previously believed that the expansion of the universe was slowing down due to the gravitational attraction of matter. The exact nature of dark energy is still unknown, but it is generally thought to be a type of energy that is spread throughout the universe, filling the vacuum of space. There are several proposed explanations for what dark energy might be, including a cosmological constant, which is a term in Einstein's equations of general relativity, or a new fundamental particle that has not yet been discovered. One example of how dark energy is thought to work is through the concept of cosmic inflation, which is believed to have occurred in the early universe. During this period, the universe underwent a rapid expansion, which was fueled by a type of energy that is similar to dark energy. This rapid expansion smoothed out the irregularities in the distribution of matter, leading to the uniformity of the cosmic microwave background radiation that we observe today. Another example of how dark energy is thought to work is through the large-scale structure of the universe. The distribution of matter in the universe is not uniform but is instead clustered into galaxies, galaxy clusters, and superclusters. Dark energy is thought to play a role in determining the large-scale structure of the universe by influencing the gravitational interactions between these clusters of matter. In summary, dark energy is a hypothetical form of energy that is believed to be responsible for the accelerating expansion of the universe. Its exact nature is still unknown, but it is thought to be a type of energy that fills the vacuum of space. Dark energy is not directly observable, but its effects on the large-scale structure of the universe can be observed through astronomical observation.